We're so pleased to be spending this time with Sir Peter Beck, the founder and CEO of Rocket Lab. Before going into our conversation, I'll just share, I don't know how familiar you are with the Motley Fool, but when we recommend companies and often put our own skin in the game with our members, we do so with a 5-year minimum holding period generally, and ideally multi-decade holding period. So we like to assess the long-term vision and mission, strategy, and performance of the business. And obviously, we don't want to put you in a position where you're having to give any forward-looking statements. So just deny any of our long-term questions that you can't answer, but just letting you know that we really are most interested in the very long term. And our greatest investments, which is not unusual for people throughout their lives, are the ones that they held for the longest period of time. Now, I love my low-cost basis of $25 a share, right around there for Rocket Lab. But Seth Jason, who's here, and Lou Whiteman, who can't be here today, have both recommended the stock and owned the stock since it was below $5 a share. So a lot of our Motley Fool members have gotten in some early low positions with the business. But I think, Peter, we'd love to hear you just outline the main components of Rocket Lab, maybe beginning with space systems, since it's easy to overlook the segment, or many may view Rocket Lab as a launch company. But can you just walk us through a walking tour of the business, please?
Yeah, totally. Well, I mean, I always like to talk about Rocket Lab as an end-to-end space company because, you rightly kind of it's sort of almost sort of bisected into two parts. Like there's launch, which is, the big roaring stick in the sky, which everybody gets excited about, and then there's space systems, which is kind of less visually glamorous, but of course a huge part of the business. But both of these elements are necessary to deliver on kind of the key goal here and the key mission of being end to end, and I think ultimately deploying infrastructure or services on orbit. And it's my view that if we're talking about the long term, it's my view that the biggest space companies in the future, it's going to be a little bit blurry about, are they a space company or are they something else? And just take our friends over at SpaceX. Are they a space company or are they a telecommunications company at this point? So it gets a little bit blurry. But I think what is absolutely true is that if you have unfettered, rapid and reliable access to space, and you can build whatever spacecraft you want to build, then your ability to deploy infrastructure or services from orbit is going to be way better than somebody else who doesn't have those capabilities. So, we're just sort of methodically going about making sure we have all those elements to ultimately deliver on that end-to-end space company goal. So I know you want to talk about space systems, but I think it's always good to kind of wrap it in the context of why space systems even exists. And space systems was really started very early on in the company's life. And I often hear people saying, well, launch wasn't big enough, so Rocket Lab pivoted to building spacecraft, and that's just simply not true. In fact, the second Electron vehicle that we ever flew had all of the recesses pre-cut into the kick stage for solar panels to turn that into a photon. So it's been part of the plan from day one. But the thing is, the most difficult thing to do and the most transformational thing you can do is have access to orbit. That's the biggest problem you have to solve in all of this. Spacecraft are difficult, but not nearly as difficult as gaining access to orbit. And that's the real disruptor here. It's not anything else. So that's kind of where we started. And then as we started to build our own satellites internally, we placed some orders for some components, and the lead times associated with them and the costs associated with them really took us back. And we're like, well, how can anybody be disruptive in this industry when it takes 12 months to get a star tracker, just a simple star tracker? So, not surprisingly, that led our first acquisition of Sinclair Interplanetary, and we've sort of never looked back from that point. And the best way to describe what we've done there is literally lay a spacecraft out or satellite out on a boardroom table, and then just systematically point to all the bits that really suck, and then go after each one of those, and either build that technology internally, or we'll go and buy the best company that currently makes that technology. and not just stopping there, but actually doing it at scale. So that kind of gives us, a really healthy ability to just think of it like a storeroom of parts that you can just go and pull off the shelf to build almost anything you want. And then kind of the next leg of space systems. I mean, there's really three kind of internal mandates that I set forward when we started Space Systems officially, and that was one. Everything that goes to space should have a Rocket Lab logo on it. Don't care if we built it, don't care if we launched it, but everything that goes to space should have a Rocket Lab logo on it. Preferably the biggest logo that you can fit on the component. And then secondly, we want to build spacecraft, but not interested in just building boring spacecraft that lead nowhere. They have to be very strategic spacecraft that, ultimately fulfill the end vision. And then the third one is like, building applications or infrastructure in orbit, which that kind of feeds into. So the components bit, we're well in hand right now. I mean, we're the largest supplier in the world of some things. Like I think we're the largest space grade solar cell provider and panel provider in the world now. And I don't know if we're the largest reaction wheel provider, but we must be getting up there. And we just keep scaling these businesses. And then on the spacecraft side, our first spacecraft was a spacecraft called Flat-lite, which was a little photon. And then we sort of skipped about a decade and went straight to the moon with the next photon. And then, because we were able to successfully build that spacecraft for NASA to go to the moon, we won the Escapade missions to Mars, which are about to launch. And then because we executed those really well, we were able to secure a contract with MDA Globalstar on a quite a big comms platform. And then we're able to win, as a prime contractor to SDA, a whole bunch of national security spacecraft. And then along the way, interesting stuff that's very strategic, like the Varda re-entry spacecraft and LOXSAT and a whole bunch of other stuff that's, that all feeds into the kind of end goal here. And the kind of a few years later, there you go. You kind of that Space Systems.
If I can do some cleanup for our members who may not be familiar with some of these terms, Photon is your small satellite platform, correct? Got that right.
So we actually have multiple platforms now. So Photon is where it started, and that's kind of a platform that integrates very cleanly onto Electron. And the original plan with Photon on top of an Electron is that we basically the kick stage of an Electron is a satellite. So we thought, well, it would be a great idea where we could just provide people a bus that they could just integrate their payloads on. And that sounded wonderful, and from an engineering perspective, it sounded wonderful. Until we actually, realised the reality is that the only reason why someone wants to integrate a payload onto a bus is because they can't even afford a bus. So the level of payloads that turn up to get integrated to your bus, these are people with no scale, no money, no anything, and it's just not a business. So, think of it like a tug business or those kinds of things. It was a great idea, but we very quickly learned that it was just a terrible business. Very ideological in thought, but just terrible. So, but that's fine. But we very quickly started to build what I would call proper spacecraft. And so the platforms we have the Explorer class, which basically they're rad tolerant, deep space, big balls of delta V propulsion. Like they've got heaps of delta V on board. So Capstone, the Escapade spacecraft that are going to Mars. I mean, those spacecraft get dropped off in a Lagrange point, sort of in L2, and then all the propulsion on board those spacecraft takes them to Mars. So they're just giant balls of propellant, which is something we've become very unique in doing. And then we have the Lightning class, which is a medium Earth orbit to low Earth orbit radiation hard spacecraft. This forms a basis for the MDA Globalstar platform and the SDA platform. Really capable machine living in a terrible environment with a high uptime and super reliability, like a 12-year life and whatnot. And then, then we also have, a couple of others, including the Flat-lite, which is a high volume comms bus platform, and a couple of others there as well.
Can you talk about the interplay as an entrepreneur and an engineer between the importance of creativity and imagination, discovery and experimentation, and how crucial it is to execute down to a layer of detail and precision that, given the business, most people would ever encounter anything like what it takes to have the conviction when you put something on the launch pad that it's time to go?
Yes, it is a raging cauldron of hell and conflict sometimes in my head, because I'm half entrepreneur who wants to take extreme risk, and then half engineer who by nature is extremely conservative. So finding the balance of, to your point, of putting stuff on the pad that actually works, but moving quickly and being innovative is a fine line to walk. So and I think it's something that I don't know. I think it's also a part of the magic of the company. I think if you're just 100% entrepreneur, and you've seen that with maybe other space companies and no engineer, the results are just real bad. And then if you're 100% engineer and then no entrepreneur, then I think you would never ever put anything on the pad, because you would be unable to take any kind of risk. So I think you have to get that balance right, and I think it's probably some of the magic of Rocket Lab is knowing where to be entrepreneurial and take risk, and knowing where just to not take risk.
Well, you're taking some interesting risk with Neutron, right? It's a different looking rocket, and as you pointed out, going to be the largest carbon fiber composite rocket flying. And CF was famously adopted and then discarded years ago by SpaceX, but you've stuck with it since early days with Electron. For Neutron, you've got one of the largest fiber laying machines in the country, if not the largest, over there in Middle River, and presumably a very large oven, right?
Yeah. Yep.
And so I guess I'm kind of a carbon fiber nerd. I make things out of carbon fiber in the spare time. And so I have lots of questions about that, because it's not easy to meld carbon fiber composites together with metal. And if, I was just looking at your recent presentation, and there's still plenty of what I presume is aluminum involved in the structure and the pieces. And mating all that together has got to be very complex, different coefficients of thermal expansion. Can you talk a little bit about some of the risks you're taking and how things you've learned with Electron on reentry heats and everything else have prepared you to shape Neutron and to kind of design the mission parameters, how you're going to slow it down without having that carbon skin, turn to, silly putty on the way in?
Absolutely. So ironically, I don't view the carbon composite as like by far any of the largest risk at all. We just have so much knowledge and experience, and I've been been building carbon fiber everything forever, and the reality is that on a re-entry, if you have an aluminum structure, like if the aluminum sees 200 degrees, I'm going to mix metric with imperial here, so I apologize. But if the aluminum sees plus 200 degrees C, which is a very modest external skin temperature, then you take all the temper out of the aluminum and it's putty. So you've got no strength left in your aluminum. You can sit carbon composite at 200 degrees C with the right resin system all day, every day, and lose no structural integrity. So your actual kind of thermal loads and managing those thermal loads on the raw structure are no different between aluminum and carbon. You'll take the temper out of aluminum if you go to 200, and you'll start to see degradation in carbon if you take it above too much above 200. So from that perspective, it's pretty straightforward. Now, the biggest disadvantage with carbon is that you have to tool everything, and then make the rocket off the tools. Now, with like aluminum, you can you can bend pieces of aluminum and friction stir weld them and whatnot, and change a lot very, very quickly. So that lends itself to to that kind of construction. So the downside is that you've got to design your rocket pretty much bang on right from the start if you want to use composites. Otherwise, you'll spend you just spend your whole life building tools. And it takes much more time to build the tools than it actually does to build the parts. I mean, the tools on the AFP machine, took like months and months and months to build. To build a stage 1 dome, for example, on the AFP machine is 11 days. Well, I think it's 12 days, thereabouts. So it's really quick once the tooling's there to bang the components out, but you sink the time and energy into tooling. So if you don't know what you're building, that's a real problem. If you know exactly what you're building, then it's great. But we could do a whole thesis on carbon, but appreciate there's other questions you had in there. But I would say that Electron had served such an incredible apprenticeship for us in many ways. An apprenticeship about how you build a rocket in the first place, and how you scale a rocket, and how you scale not only just the vehicle but also all the operations. And the reality is that Electron ASP is around about $8.5 million. Now, range safety and all your launch pad and licensing functions don't care if you're launching a rocket that costs $8.5 million or a rocket that costs $70 million. And we just had to find a way to make all of those processes and all of that work extremely efficient, because some things scale with the size of the rocket and some things just don't. And the overheads don't. It just doesn't matter. Like if you're operating a launch site that's got a pad that weighs 100 tons or 10 tons, the cost of operating that launch site is the same. There's the same number of people. So you're just forced to be ruthlessly efficient with every process and every piece of infrastructure. So it almost feels like a luxury, now doing Neutron, where even from a technical perspective, like on Neutron, we care about 100 grams. We really care. We obsess about 100 grams. With Neutron, 100 grams is totally irrelevant. So you can spend a lot less time worrying about those kind of things. And then when you think about range ops and all of those things, our systems are just so ruthlessly efficient that it just puts us in a great stead. And then on like things like recovery, which is the thing we haven't done with Neutron and done very little on in comparison with Electron. We flew 10, I think it was 10 Electron recovery missions, and man, I would not have wanted to take on Neutron recovery without doing that, because we just learned so much. And even today, there's bits of Neutron that fly on the rockets, fly on the sides and inside Electron. We're still using Electron as a test bed for materials testing, software testing, hardware testing. Today on Electron. So, it's served such a great learning tool that when it comes to things like re-entry trajectories, we have them nailed. When it comes to understanding the thermal environments and validating those models, well, we actually got to build a model and validate it with real data, which nobody gets to do. Usually you're that bit of it, you're flying blind. So no, it's served an incredible opportunity to de-risk that program so much.
It feels to me like most of our questions will weave between engineering and entrepreneurship. So perhaps you can continue to blend those by telling us the process of making acquisitions to be a payload provider, to own the payload, why that's significant, and how far you are in that process, how complicated it is to assemble that, and why it matters.
Yep. So, I mean, we've basically got all the bits and pieces of the satellite. There's a few bits there that we haven't quite got, but we've pretty much got everything that we need there. And you really quickly learn that people don't buy satellites for great reaction wheels and solar panels. People buy satellites for the payload and what it does. And if you're never going to scale to a giant company if you just provide buses, and you really have to provide the end-to-end solution. So, you've seen us start to dip our toe into payloads now, and electro-optical is kind of the first piece of that. And if you think about how many providers in the world are there of these deeply complex electro-optical infrared kind of payloads, you can count them on one hand. So being able to provide that payload to other people's spacecraft is one thing, but when you turn up all of a sudden to a customer and you can provide the thing that they actually want to do, being the payload, and by the way, all of the bus, all of the operation systems, all the ground segment, and we can launch it for you, it's just a totally different proposition. So you'll see us acquire more of more of those payload kind of elements, because I think that's kind of the last piece in the puzzle.
Something along similar lines, I cover a lot of our AI stocks here, and sovereign AI has become a thing for various reasons right now. And it sounds a little bit, to hear some of the recent space talk, that sort of sovereign space launch is kind of shifting in a similar direction. And I think that your recent acquisitions maybe kind of nodding at that. And so how do you think about those kinds of markets going forward between sort of Europe, Asia, the US? There are some obviously you'll never serve. But is that part of the strategic thinking going forward?
Yeah, so look, every nation is, and I would say there's been a recent kind of retrenchment in that, in the fact that nations have with various world events have decided that actually we need our own stuff, and so there's definitely certainly a strong desire there. We've always seen it a lot from launch, because any kind of emerging space nation always wants their own rocket because it's just super cool and very, very visible. So we've always always been approached a lot with, can you come to our country and build a launch site, and it's like, I don't want to build another launch site ever, so why would I do that? So but there's no strategic reason to do it other than a country wants a launch pad, but they have to service that launch pad and that demand with their own sovereign spacecraft, and maybe that will happen or maybe that won't. But certainly, yes, we're definitely seeing a lot of sovereigns looking to create their own capability. And to your point, the Menark acquisition that hopefully we get through in Germany is it's a fantastic product. It's a laser terminal. It's incredibly needed across our platforms and many others. So in its own right, it's a great acquisition. But also, it really is our first step into Europe, and we're not stopping at just becoming large in the United States. We want to service the globe and the countries that we can work in. So that's kind of the first step into Europe.
Just a succinct light question for you about investors in Rocket Lab. If an investor today wanted to align their time horizon with your time horizon as an investor, how long should they be thinking about holding the stock? There's so much of a transactional dynamic in the public markets with a lot of information. One of the biggest challenges we face at the Motley Fool is to teach the importance of finding something that you want to be an owner of, and the benefits of that. So the dream is to align with the CEO's time horizon. Now, some CEOs are very transactional themselves, and so everybody's at a different pace with a different time horizon on their vision. What's the proper time horizon to align with your vision?
Well, I'm not going to provide financial advice here, that's for sure.
Darn.
But I would say, but look, I'm trying to build the biggest space company in the world, and gee, I would have hoped to have done it by now. Everything always takes too long, right? But you have my commitment that's my goal, and I'm just my shoulder is down, and I'm running as hard as I can to do that, and so is everybody in the company. And how long that takes is how long that takes. But I think you can see we kind of consistently keep growing and scaling the company, and everything consistently moves up and to the right. And there's, hopefully people see the methodical path that we're trying to walk here. It's like, as I mentioned right at the beginning of the call, there's like, a $20 billion opportunity in launch, a $30 billion opportunity in spacecraft, and a $350 whatever billion opportunity in applications and services. And the faster you can get there with something that's really disruptive, then the bigger of a space company you can actually build.
And in that spirit, can you talk a little bit about the culture at Rocket Lab? A company that's squeezing years of hours into a month, yet also trying to build something that will succeed for generations. How do you align the work, not burn out in the process, and match it with something that's designed to sustain as an independent company for decades?
Yeah, look, I mean, it's fair to say if you want work-life balance, don't come here. And if you look at our competitors, they don't have work-life balance anyway either. So, if you think you can compete with your competitors and not work as hard, then that's going to be a bad surprise. So, we absolutely push hard, and I would say the culture here is we have a number of really kind of non-negotiable elements, and right at the top is we build beautiful things. And I just absolutely believe that if you build a beautiful thing, that it generally works. And when you give someone the freedom to build a beautiful thing, they take so much pride in it, and they look well past their work into other people's work, and you can go and look at any Rocket Lab spacecraft, any Rocket Lab component, any Rocket Lab rocket, and they're almost beautiful, so beautiful they're artistic, and that's the way it should be. And whether it's a piece of code, a piece of software, a boardroom table, whatever it is, it needs to be beautiful. And I think where a lot of space companies have gone wrong is they try and see how crappy they can build stuff and get away with it, whereas we're the opposite of that. And the number one thing that must be always true first in space is it has to work. Everything else is kind of behind that, is it has to be second. So, making sure that everything is beautiful is something that everybody is really focused on. And it's a self-fulfilling prophecy as well, because you attract people that want to build beautiful things that work. And people who want to take shortcuts and not present the best work that they can do don't survive. They either realize that it's not the environment for them, or their peers around them don't accept their work. So it's self-fulfilling. And if you look at the launch companies that have, over the last, call it 5 or 10 years, it's not a good bet. Generally, they all fail, right? And I'm always asked, well, why did Rocket Lab succeed and all these others failed? And it comes down to really two things. It comes down to building beautiful things, and it comes down to hustle. And when I say hustle, I mean, when you're greeted with a barrier, you have two options, right? Is you can either just throw your arms up and go, well, I don't know what to do, and this seems impenetrable and can't solve it. Or, you try and climb it, and if you can't climb it, you try and go around it. If you can't go around it, you get out your spade and you just start digging until you get under it. So, and that's the Rocket Lab kind of mentality. So where many others would have reached kind of points in both technical or otherwise and given up, I think we just have more tenacity than others.
It feels like there's a bit of that in your expansion into some of the newer markets. I'm thinking in terms of HASTE, and which is kind of a repurposed Electron, right? For folks who out there who aren't familiar, it's a hypersonic test bed, sort of. Is that a good summary? A good way to express it? I was reading a little bit more about that over the past couple of weeks in preparation for this interview, And I didn't realize there's a little more competition in that space than I expected. I was thinking of who was it? One of your Stratolaunch, one of your competitors in there that's launching a small vehicle from an airplane. And allegedly the price there has come down to about 3.5 million. How does is that a fair comparison in that space to an Electron launch, an Electron haste launch, or are we talking about different kind of capabilities there? Sort of what's the spectrum of testing that's going on right there, and maybe fill in our members on kind of the how we're just trying
Mm.
to start catching up in hypersonics in the U.S. from we were doing maybe one launch a year for a couple of decades in this country.
Yeah, yeah. Well, I mean, look, uh, man, Electron has so much energy. It's ridiculous, and so much accuracy. It's ridiculous. You know, look. We've done 5 launches now, and you know, the accuracy that we're able to achieve with that vehicle is just enabling entirely new levels of goodness in research. And it's funny because, you know, when we first started talking to these customers, it's like, well, they need Mark 5, maybe Mark 8. And it's like, okay, well, you know, we take 320 kgs every 2 weeks to Mark 27, so this really isn't a problem. So the vehicle just has so much energy and so much capability that we can do anything. And because it's a liquid vehicle as well, you know, we can throttle engines, we can stage, not stage. It's just infinite. So, you know, I've seen a lot of happy customers. I'm not sure I've seen customers as happy as these ones on haste. So it really is a massive unlock, and you know, a massive you know, advancement in the ability to test. So, you know, we're expecting you know, we'll continue doing mini haste launches from now and into the future.
And we can't hear anything about those payloads for the most part.
No.
That's true. Rats.
I was wondering, in terms of your personal journey, what effect the force of doubt from others has had on you, whether it's something that you experienced early in life, or just being in the process of bringing truly new innovations to the world that and into a marketplace where you will encounter in the public market somebody who is shorting your stock, or an institution that just told us that just decided to sell a substantial amount of their position or their entire position. So what effect, if any, does doubt have on you and your work?
That's an interesting question. Well, I think it's important to listen to people who doubt you, because you have to be ready for the possibility that you are wrong. So it's always good to hear that. But I guess reflecting, I'm from the smallest town at the bottom of the South Island of New Zealand, with a country that had zero space industry. So I don't know, if you had too much doubt, I'd be on a farm milking cows somewhere. So I guess obviously not that much of effect. But
There's an expression.
I think it is important to listen to those people, even if you disagree with them. I don't think they should be silent, because I think you need to realize that you can be wrong, but they can also be wrong too.
Oh, go ahead, Seth.
I was going to say along those lines, folks who are familiar with your origin story, I'll try to give the brief version, and you just start laughing or point at me when I get it wrong, which is you're somewhat self-taught, worked as a machinist really, and backed into the engineering part and worked into rockets from there. I'm wondering in terms of, you know, self-doubt or growth, when things started to get complex, sort of when did the maths become an issue where you said to yourself, like, now I really need the eggheads to come in here and and take care of some of the stuff that maybe as a machinist was less familiar, or did you just go out and tackle all of that yourself? At what point did you start to need staff to say, I need the support to move in this direction? And when did that happen kind of in Rocket Lab's development, the company?
Yeah, well, I mean, look, my plan was always to go to university. It's just that the university courses that are available in New Zealand were, somewhat aligned to other things other than aerospace. And, I was building rockets when I was at school. And the truth is that I wanted to do a tool and die making apprenticeship, or machinist, because I was building rockets, and I felt that I wanted to build the things first. And I always believed that the best engineers are ones that can, make the thing that they design. And, even today at Rocket Lab, a design engineer has to go down and assemble the thing that they made. Because if they've made a real nasty feature, they should learn about that nasty feature first. Because you only need to do that a couple of times, and all of a sudden, you really start to think about how you design your components. So I always believed that, and the plan was always to go to university, but sort of opportunities kept presenting themselves that I never really got there. And in the end, the Auckland University just gave me a professorship in the end anyway. So I got the piece of paper in a roundabout way. But no, I would just engineering is engineering, physics is physics. It's just the same. And there's certainly well smarter people than me, for sure. But I would say that I have a healthy kind of dose of knowledge and experience in a bunch of the areas. And I'm still the chief engineer for the company, so when the big hairy decisions with big consequences and no information need to get made, then that still falls on me. And wherever possible, I spend as much time in design reviews and all the rest of it. And I'm dangerous enough that if someone presents me a finite element analysis that doesn't look right, I can call BS on it, and likewise on many things. So, but I think the true kind of scaling of the business really didn't happen until we raised our first bit of cash from Koesler Ventures. Way back in 2013, 2014, that's when we could hire, in truth. Prior to that, the company was just alternated between sort of 3 and 10 people, depending on what we were doing.
You talked about the design review process and getting involved in it. Can you explain or express your product development process at Rocket Lab?
Yep.
Maybe compare and contrast with Apple, or however, how would you say that? What are the key elements of moving from the initial idea to completion?
Yep. So we like to fail fast, but we never like to fail fast at a big scale, if that makes sense. So by the time something gets to a big integrated test, then nobody expects it to fail. But we could fail fast on subscale and elements that we think are high risk, or components or bits and pieces we think are high risk. And some folks have the resources to be able to fail fast at a big scale. We've just never had those resources, so we have to be very, very expeditious with our resources. If we're looking at a program, we'll identify the things that we believe are high risk. Sometimes they are. Sometimes the things that you thought were low risk were high risk, and sometimes the things that you thought were high risk were low risk. But anyway, you do your best job there, and then you take those bits out to the back and you try and fail them fast to determine how big a problem is this going to be, how big a research program is this going to be to solve it, and then we're just I would describe our process as just incredibly thorough. Every bracket, every harness, every sensor, everything on a launch vehicle or a spacecraft goes through full, qualification and acceptance testing. And it's very tempting to you've got a bracket that holds a valve, and you might go, well, why do we need to go through a full vibe and shock and thermal environment program on that stupid? It's just a bracket holding a valve. Well, there's plenty of times where that bracket can hit a structural resonance that can resonate and and all of a sudden you've got a valve that's cycling at a high amplitude, and maybe the valve's got a spring in it because it's a solenoid valve, and that couples. Then the solenoid valve starts chattering, and then that's connected to your press system, and all of a sudden your press system goes haywire, and you blow up a rocket. And that's just the reality of the way things go in this industry. Like, the failures are never like the big things that you've tested. The failures are always, kind of, admirations of little things that kind of go on.
Has it been a challenge to find enough machinists, engineers, and others here in the States and elsewhere to get all this done? I mean, if you're
Yep.
needing to test brackets and redesign brackets for a whole new program, that's got to take some good people.
Yep, 100%. I would say that for the longest time, and even today, the company is throttled by how the resources that we can bring on, and we also make no kind of apologies for only hiring the best. The PNC team were telling me relatively recently that it's twice as easy to get into Harvard than it is to get into Rocket Lab, and we just have so many CVs come across the transom, which is great, but the folks that make it through and have the right both technical ability and the right kind of cultural match is just quite a small subsection of that. So and I know it's frustrating for some of our hiring managers because I'm sure some days they just want a pulse, but we just the process will just not allow that ever to happen.
Should we rename, a couple wildcard questions here as we move to the close. Should we rename the company Rocket Labs since we're doing so much?
Yeah, no. If we're going to do any renaming, it should be Space Labs or Space Lab or something, because it's a funny story. Actually, why it got called Rocket Lab is when I first started. Obviously we were building a sounding rocket to start with, and in a very typically unimaginative engineering approach, it's like, well, the name must simply have rocket in it because that's what we're building. And then the reason why I chose lab is because in New Zealand, someone building a rocket was viewed as a complete crazy person. So I put laboratories on the end of it to try and legitimize what we were doing and to make it sound a little bit more technical. So it wasn't just like sounding like some crazy guy building a rocket. And that's the truth about how Rocket Lab got its name.
It was a little Goddard-like, I thought. If we're into the the wildcard section, I've read a few versions of your origin story, and they all have this cryptic reference to one of your first trips to the States and how you met with someone in Minnesota, and then there's no more information. Now, as a homegrown Minnesotan and a proud Minnesotan, I have to know more about the Minnesota trip, which is always mentioned. Was it that consequential, or is this just what's the story?
Yeah, so in Minnesota is a guy named Kai Michelson, and Kai Michelson goes by the name Rocket Man. And he was responsible for all of the crazy rocket cars and motorbikes of the 70s and 80s, maybe even 60s, 70s and 80s. And he was very famous in the stunt world. Built a lot of the peroxide dragsters that set crazy quarter-mile records and all of those kinds of things, and rocket packs and just crazy stuff. And growing up in New Zealand, I built rockets and for better or worse, put them on bikes and scooters and jetpacks and all those kinds of things myself. So that was where the Minnesota element came through was Kai Michelson.
I have never heard of that. Now I have to look that up. When I heard the story about the steam rocket powered bicycle that did 100 miles an hour in the parking lot, I wanted to know what was the braking system, because that's my first concern if I'm going to go 100 on a bicycle.
Yeah, that was problematic actually, because it was 20-inch BMX wheels, so the surface speed, and this is well before disc brakes were even a thing. Like the surface speed of a rubber pad on the rim was just not well matched. So at 100 miles an hour on BMX wheels, if you put the brake on, I can tell you for the absolute fact that those rubber pads just melt instantly, and there's just billows of smoke come off your rim and nothing happens. So the only way you slow that down was to just sit up and become a sail and just let the wind slow you down for a while. And then once you got to sort of 100 kilometers an hour or 60 miles an hour, that's when you could put the brakes on. They're fine below about 60, they're fine.
Well, we're continuing in the wildcard section, so everything that we do communicates, and you're on social media and on your Twitter account, you consistently report on what is happening with your company. A friend of mine who really evaluates public companies and leaders based upon their soul, skin, heart, soul, skin in the game with that business, has also become a little bit jaded because as she looks out across the success stories in the commercial world, starts to see more and more CEOs become, in their own view, omni-domain expert with views on everything and maybe loosening up to allow narcissistic elements to be expressed because they have built something that is successful. So should we expect to continue to see you delight in all of the work that your teams are doing at Rocket Lab, or should we expect to see pictures of your yachts and your worldviews on many things that would seem to be unrelated to your daily work?
I think what you see to date is what you get, and I don't see that changing. In fact, I have to be prodded constantly by our comms team to just tweet anything. I was put on this planet to do one thing and one thing only, and all those other things. It's a joke with my executive team that I'm so focused on just one thing that any of the movie references just go over my head. Any of the political references just go over my head, and I'm just completely, just completely redacted from the world in many of these things. So no, I think you'll be safe.
The irony is you'd be one of the few who could perhaps design their own yacht because of your experience in that realm, right? Which you described as as one of the most difficult jobs, or scary. I'm trying to remember what it was.
Yeah, no, it was very difficult in the fact that I came from an environment of measuring in microns to then an environment of measuring in inches, and also it actually taught me. I really did enjoy that experience for many years, but in hindsight now I realize just how important that was, because in the morning the owner of a super yacht would fly in and change the knobs of the cabinets to titanium spheres, and then in the afternoon I'd have to work with fabricators who are completely illiterate, and be able to communicate and get along with those people and have a beer at both ends of the spectrum. And I think that was a really great time and a lot of learning where you kind of learn about how to get what you want from very, very different people.
Good CEO training.
Yeah, really. Yep.
What companies outside of your category and inside of your category or organizations do you admire?
I told you that I only have one focus, right? This question is very. There's not a lot outside Rocket Lab. If I'm really
clearly,
honest.
I wasn't listening to your answer by
No,
asking that question.
Look, I mean, in an industry, you have to admire, what Elon's built. I mean, it's just incredible, and I think also what Jeff has built as well with Blue. I think in time that will become obvious. What capability he's created there. I think it's going to be pretty impressive. Look, anybody who successfully gets to orbit. I bow to them because it is ridiculously difficult. So that's a huge thing. And then outside rockets, I I fly jets and helicopters and mine for gold. That's it. It doesn't go much past that.
Mining for gold. I missed this
Yeah.
part. Mining for gold.
Yeah, I really, so it feeds all of the things that I love. So from a capitalist perspective, I get to dig in the dirt and get paid. Like that's crazy, just finding money in the dirt. So I enjoy that. That's a Scottish element of my upbringing, really coming to fruition. And
Are you
then,
out in are you panning in a creek somewhere?
yeah, panning in a creek. Well, like anything I start, it tends to not stay at small scale. It tends to grow. But yes, it started panning in a creek and ended up in a digger. But the point being, it's amazing to think that gold that came from collapse of supermassive black holes and supernovas in the universe. That's how the gold was created. And here it is, like the formations of the universe that I'm digging out of the ground, and it's worth money. It's like you couldn't imagine the most satisfying thing. It just soothes all of my needs. And it's a great thing to do with your family. It's a great thing to do when you just need some thinking time to just pick up a shovel or a digger and just dig away. And at the end of the day, sometimes you find something and sometimes you don't. It's so much fun.
Is this in New Zealand or out in California?
I've done it in New Zealand and California actually. I went and I can't remember where it was, but it was in this little river in California that I went with a friend there, and we found a little bit. Yeah, it was great.
We learned
We'll
something.
respect your time. And oh, sorry, Seth.
We learned something new today. That one I hadn't heard.
Oh, everybody should
we
try it. Everybody should try it. It's so much fun. And if you've got kids, like I challenge you for any kid to not, be panning away and then slowly reveal a bit of black sand and a speck of gold. I've never seen a kid who isn't just incredibly excited by that.
We will end on time. So this will be my last question, but Seth will get the final question because of all the great work you've done, Seth, and covering Rocket Lab and any other companies as well. There is the expression that we live two lives, and the second one begins when we realize we only have one. So what was the impact, if anything, on your mindset from being in a head-on collision at the age of 16? I believe you had a car collision. Was that the beginning of your second life when you realized you walked away from something, or maybe you've had many of those?
No, that wasn't that. Look, I was 16, bulletproof. That didn't have that bigger impact. It was like, don't do that again. That hurt. So certainly not one of those transformational moments in your life. For me, really, I would say it was, when I went to the States and, tried to get a job in the space industry, and that just became very, very obvious that was going to be extremely difficult and even if successful, not that impactful. So, that's probably, if I look back in history, probably one of the most impactful times was like, okay, that's not going to work. We have to go and start our own company and make it happen.
I don't think I can top that.
You might surprise everyone by sharing this, although I think I have a similar personality trait. You're not interested in going to space. You admire the astronaut and the risks that they're willing to take, and you take that mission so seriously for many other reasons than that, but as a multiplier for that. And alongside that, as you create this company that we've come to love so much already, you don't have an interest in traveling into space yourself.
No, I have just tremendous admiration for an astronaut who can sit in there, and in many cases they're good engineers themselves, and just turn off that thing in their brain that is going through all of the, has that been lock wired, has that been torqued, is that good? Like I just could not understand how you could sit in there and just turn that off and then commit, and then not only commit but perform. I mean, on a launch day, don't ask me to do anything of really great significance, because at least for the couple of hours before and after launch, I'm not sure I'll be making great decisions.
Sir Peter Beck, the founder and CEO of Rocket Lab, ticker symbol RKLB, naturally will be a very volatile stock. Many of the greatest companies have very volatile stocks as they bring something into the world that others try and figure out how consequential it will be, what risks they will need to endure as a shareholder. And so we're excited to be on that journey with you and your team and your company. And we wish you the very best. And thank you for 60 minutes of your time.
No, thanks very much, guys. It's been fun.